This is a lesson on significant figures, which has to do with recording measurements properly to reflect the precision of the instrument you are measuring with. When taking a measurement, you will record all the numbers you are certain of plus one estimated digit. This measurement to the left, right here, would be recorded as 33.5 milliliters. You always read the bottom of a meniscus in a sample of water in a graduated cylinder, so you're reading right to that spot right there. We say that this measurement has three significant figures. What I'm counting here is the 3, and the 5. All three of those digits are considered significant to the measurement. We are certain that this measurement is at least 33 milliliters right here, but it's less than 34 milliliters, which is that spot right there. You then can estimate between those two values. You wouldn't just say the measurement's 33. You wouldn't just say it's 34. You can pretty confidently estimate somewhere between that 33 and 34. We said that we estimated it to be 33.5. If you were to say 33.6 or 33.4, you would not be incorrect because that last digit and the tenths place is an estimated digit. However, if you said 33.1, that would not be a correct estimation. The estimated digit, in this case the 0.5, is considered to be significant because it conveys meaning about the precision of the instrument. The measurement to the right in this diagram would be recorded as 43.0 milliliters. Even though the meniscus falls exactly on the division mark, you must still include the 0 as the last estimated digit to convey that your measurement reflects the precision of the graduated cylinder. The smallest division on this graduated cylinder is 1 milliliter. And it means that you estimated the measurement to the nearest tenth. We say that this measurement has three significant figures. The 43.0, the 0.0 is to the nearest tenth. That's your estimated digit. Of course, in your calculator, you would not have to type in the 0.0, but to reflect the precision of the instrument, you include that last estimated digit. For the measurement of this object against the ruler, we are certain that the measurement is at least this value, which is 0.035, and it's not more than this measure. It's not more than that value, which is 0.036. Okay, so it's 0.035, between 0.035, but not more than 0.036 centimeters. We then need to estimate one more decimal place between those values. Okay, a good estimation here might be 0.0356 centimeters. The number of significant figures in this measurement is also 3. This might be confusing. The 3, the 5, and the 6 are considered significant, but this leading 0 is not considered to be significant. It ends up being a placeholder for the measurement. There's some rules to follow in figuring out the number of significant figures if you are given a measurement and you are asked to figure out how many significant figures there are. The first rule is very straightforward. All non-zero numbers are considered significant to the measurement. So the number 2.15 has 3 significant figures. The number 56.341 has 5 significant figures. So that's very straightforward, but when it comes to zeros, it gets a little trickier. For zeros, it depends on where the zero is in the number that you'll be able to tell whether or not it's considered to be a significant figure. If the zero is a leading zero, that means it's at the beginning of a number. These zeros, leading zeros, are never significant. They're considered placeholders, and you don't count them in your significant figures count. So the number 0.0023, the first three zeros are not significant, but the 2 and the 3 are. So this has two significant figures. In the number 0.12, the first zero is a leading zero. We're not going to count it as a significant figure. But the 0.12, both of those digits are significant, so there's two significant figures. So leading zeros are never significant. Captive zeros, sandwich zeros, zeros that are trapped in between two non-zero numbers, will always be considered significant. So the number 23.001, those two zeros that are sandwiched in the middle there, both of those are considered to be significant, and so this measurement has 5 significant figures. 205 has 3 significant figures. So captive zeros are always significant. Zeros that come at the end of a measurement are a little trickier. Sometimes they're significant, sometimes they are not. My recommendation to you is that you look for the presence of a decimal. If there is a decimal present, you will count the zero to be significant. If there is no decimal, you will not consider the zero to be significant. So the number 7,800 has no decimal in it. So this measurement has 2 significant figures. We would say that in this number, in this measurement, this value was estimated to the nearest 100. So this is not a very precise graduated cylinder. In the second example, 7,800.0, with the presence of a decimal in this number, we then say that these ending zeros are all considered to be significant, so there will be 5 significant figures. We can say in this measurement that this measurement was estimated to the nearest tenth. This is a much more precise instrument than the first example here. The third example can either be written as 7,800 with a decimal at the end, or as I have it here, 7,800 with a bar over the zero. If you see it written with a decimal at the end of a number but nothing else following, that indicates that the zero in the ones place was the estimated digit. Sometimes you'll see a bar over a zero. That's to tell you that that's the last significant zero in the calculation, and you should count all the numbers up to and including that number. So either one of these examples conveys the same information to have 4 significant figures.